Good afternoon, everyone. This is Bao Xiao from the International Marketing Team of 4DH, and I am your host of today's webinar. Thank you all and welcome to 4DH's Global Webinar Series, and today is session 3. Before we begin, a quick reminder, please follow our LinkedIn and Facebook pages to stay tuned to our latest news. You can just scan the QR code in the left corner of this page, or you can find the chat box from the right corner of your panel. It's like the icon is like a bubble. You can click it and you can see the links provided in the chat room. And today we are going to talk about spatial computing and vision language model with our 4D CAN-CAN MOVA in mining and energy digitization solutions. And before we invited our presenter of today, I will start with a brief introduction to who we are and what we make. This is the agenda of today. Who we are 4DH, founded in 2014. 4DH is a leading spatial intelligence tech enterprise. We independently develop full-spectrum multimodal 3D scanning hardware and self-built editing platforms. And our headquarters are located in Beijing and Zhuhai City in the Greater Bay Area in China. So if you plan to visit us, you can check the spots on your Google Map. Powered by proprietary AI 3D reconstruction algorithms, we deliver end-to-end spatial digitization solutions covering patent hardware, cloud platforms, and vertical services for industries like cultural heritage, AEC, smart city, and mining and real estate, and etc. Our 4D CAN-CAN series products have supported clients and partners across over 40 global markets. And you can see we've built solid technical credibility over the years with 108 authorized patents, 223 copyrighted software programs, and 73 top-tier domestic and international industry awards, including the Vietcom International Media Festival Grand Prize for 4 times. Now let's take a glance at our key milestones. In 2014, our company was founded with core tech. From 2015 to 2016, we broke ground in cultural heritage digitization, built a fully digital Han Dynasty Historic Museum for relic holographic preservation. And from 2018 to 2019, we stepped onto the global stage with our 4D CAN-CAN Pro, the 3D camera with 8 lenses, and presented at Germany's International Museum Congress. From 2021 to 2022, we launched our 4D CAN-CAN Mini and our 4D CAN-CAN Mega. Also, we partnered with China Air Show to present a cloud air show during the pandemic time. In 2023, we released our 4D CAN-CAN Meta, setting a new industry benchmark, balancing precision and mobility. In 2024, we expanded our APAC operations, delivered landmark projects in Japan and Thailand. In 2025, we released 4D CAN-CAN MOVA nationally, and also we won the ICON International Award for the 4th time. And this year, we plan to release our 4D CAN-CAN MOVA internationally, and also aiming for the mining industry, which will be covered in today's core sharing session. Then I would love to proudly introduce our brand 4D CAN-CAN to you. CAN originates from the Chinese word for see and view, representing our goal to capture every spatial detail of any environment. It also echoes with the English word can, which means we hope to empower you to unlock every possibility hidden in physical spaces with our capture technology. Just as our slogan for the 4D CanCan series product, let space tell the story, and also finally realizing our mission of 4D age, digital everything. Then let's quickly overview our 4 specialized 4D CanCan series products. The first one, our 4D CanCan MOVA, which will be talked about also in today's sharing session, which is mobile, optimal, versatile, and authorized. First, why we call it mobile is quite obvious because it's a lightweight handheld device that allows one personnel for one-hand operation. Then why it's optimal? Our 4D CanCan Pro, you can see here on the left part of the picture, it has a non-rotating dual LiDAR design, which shows industry-leading 5mm point cloud precision, engineered to capture sharp, reliable spatial data across rugged, complex sites where traditional scanners struggle. Thirdly, versatile, which is also the biggest differentiator. Our 4D CanCan MOVA's multi-module ecosystem, we support simultaneous dual capture, which means you can run full site spatial mapping and also specialized module scanning at the same time, which eliminates repeated site passes, drastically cutting field labor hours. And also we are actively developing more plugins to expand the functionality in long term. And you can see in the left corner of this page, we already have like 3D Gaussian splatting module, RTK module, and also the millimeter level LiDAR module, which makes MOVA Pro, and the sub-millimeter level scanning module, which is designed for scanning small objects. And let's watch a video of our 4D CanCan MOVA and MOVA Pro together. MOVA and MOVA Pro. Next is 4D CanCan Meta, which is dual ways to explore dual gains to record. This is our hybrid all-in-one scanner that merges two complete capture modes into one single unit. The wearable SLAM scanning for dynamic on-foot mapping and tripod-mounted terrestrial laser scanning for stationary high-fidelity surveys. Like you can see on the picture, the first one is about the wearing slum, and the third one is the TLS. And meanwhile, you get two deliverables from one capture session. First, the point cloud data, powered by a 905 nm LiDAR with 70-meter range and 200,000 points captured per second. You will get accurate, dense point cloud data. The second gains you will get is the 16K Ultra HD panoramic imagery, which is captured by the Ultra HD camera. So with our 4D content meta, you have dual ways to explore, dual gains to record. And also, Meta supports a full suite of interchangeable plugins like RTK, field light, thermal, and multispectral camera. And also, there will be more plugins in the future. So if you need flexible multi-modal data across mixed site conditions, Meta is your streamlined multi-purpose reality capture workhorse. And here is a video about our 4D content meta. This is about our 4D CanCam meta. Now let's watch a video of our 4D CanCam meta and 4D CanCam Morpha Pro with a rubber dog, which makes the rubber dog patrol mode. Next, about our 4D can-can medium, the camera, which is simple to capture but powerful to share. This is a professional-grade 360-degree panoramic camera engineered for crisp, lifelike spatial visualization with native support for 8 to 16K HD outputs. And the operation couldn't be simpler. Just one 360-degree rotation generates seamless, distortion-free panoramas in minutes, cutting out complicated setup and time-consuming post-production editing. This is most suitable for industry like real estate, which we have projects in Thailand use the 4D can-can medium. And next is our 4D can-can Mega, the top-tier, most advanced reality capture device. This is definitely the professional choice for large groups with large-scale industrial, urban, and infrastructure projects. What makes Mega ultra-professional, like you can see in the slides, it integrates 3 high-speed LiDAR sensors, which generates 300,000 point of data points every second to capture every fine detail of massive, complex environments with unmatched geometric accuracy. And also, it has one HD lens, which produces 16K panoramic imagery. So when your organization requires the most powerful comprehensive capture system on the market, 4D can-can Mega is the choice. This wraps up the quick overview of who we are. Hope you already remember we are 4D and what we make, the 4D can-can series products. Now, let's welcome our speaker of today, Julian, key account manager from our global business team, and he will guide us through the core agenda of today, showcasing our 4D can-can MOVA for mining and energy industries. Julian, is all yours.
All right, thank you, Belle. And just video. Okay. Thank you, Belle, and thank you again, and a very impressive introduction of our company 4D and our 4D can-can product series. I hope you can have a brief concept of our company's concepts and our series. So good afternoon, everyone. Again, welcome to today's webinar session. Spatial Computing and Vision language model and our 4D can-can MOVA mining and energy visualization solution. Today we will follow one concept story. First, we will look at why mining and energy sites need to change. Then we will define a workflow that can create reliable digital evidence. After that, we will introduce the capabilities of VLM-empowered 4D can-can MOVA and also apply the workflow to 6 business scenarios and finish with 2 field cases before returning to the overall value. Okay. So let us begin with spatial intelligence. Visualize the field workflow to streamline and mining digital engineering records and lower overhead costs. And obviously, these practical demands are showing that the same foundation are reliable, repeatable, and traceable records of physical spaces. So before discussing our solution, so let us look at the pressure on today's field teams. So nowadays, there are 3 practical pressures. First, survey can be slow, and conventional workflow often require repeated equipment setup, station installations, and manual coordination. So especially when stockpile, tunnel, or infrastructure surveys are delayed, so decisions are delayed as well. Second, there is a field exposure. Surveyors may work near the high walls, toxic gas, unstable ground, or accident scenes. So reducing time in this area is directly connected to safer operations. And third, there are data gaps. Scatter files and inconsistent formats can force teams to repeat measurements for inventory, beams, audits, and handover. So the deeper issue is not only the survey speed, right? So it is the separation between the field work, the safety, and documentation. So in engineering experience, potentially 5 times productivity gained by reducing repeated setup, and maybe potential 18% reduce in survey time. So yeah, obviously these are the objective factors we faced. So let's go to the objective factors. So international mining and energy projects are evaluated through the local law and international ESL guidance and lender expectation and industry standards. And across these references, the expectation is similar: to protect people, to meet EHS baseline, and show the evidence. And project needs to demonstrate what is expected, and when, and who revealed it, and what was found, and of course, what action followed. And the references should there include the IFC and World Bank General EHS guideline, mining guidance, golden tiling standard, and wind energy guidance, and have aligned stakeholders, and they do not replace the local law permits or the project specific requirements. So there's the key takeaway is that the real requirement is traceable digital evidence, not just faster scanning. So a real 3D record becomes valuable. It can be connected to a time, a location, a measurement, a review, and decision. So for field teams, this requirement can be expressed as one question. And your team be proof that it was captured, what changed, who reviewed it, and how decisions were made. And teams need to understand risks before works begin. That is an initial, really important initial preparation. And track changes through repeatable surveys and maintain traceable 3D models and measurements and CAD outputs, photos, and of course the reports. So they also need to preserve incident scenes quickly and support remote experts to keep people out of unsafe area and control the sensitive data through offline or private cloud deployment and open exports. So maybe this sounds like a separate feature, but they are outcomes of a well-designed field workflow. So the next slide is showing a nice workflow. And the core workflow is capture, model, and measure, compare, and report. Let's just break down this keyword one by one. So capture, the site with SLAM LiDAR and image and appropriate modules include a GPS denied or high-risk area, sometimes in the underground environment. And second, the model data is 3D point clouds, panoramas, and digital twin information. Measure what matters, the volume, the distance, the deformation, and also the CAD deliverables. And fourth, our compare data from different time periods to identify the changes and the deviations. And our last one is report and export evidence for operations, safety, and engineering management and audits. And this is not a one-time scan, right? This is a work loop, let's say. It's not a straight work line. It's a repeatable loop, and so teams can return to the same sites, update the record, and compare it with the previous condition and for the changes. So this creates a principle of capture once the reuse many times, and the same spatial time can support operation, safety, engineering, and audit workflows. So when we evaluate the product series Mova and Mova Pro, so this question is not only what the device can do, the question is where the complete workflow can create measurable optional value. So now we have defined the problems, and it took maybe 10 minutes to go through how is the problem story goes and the workflow. So just let me introduce the capability layer that supported VLM empowered for the Kankan Mova. So in practical terms, like AI agent is really popular in our workflow, in our daily work, like an OpenAI and Cloud Code. However, the VLM is the intelligent layer connecting visual data, 3D space, and natural language interaction. It helps teams understand, describe, search, and even communicate complex field data more easily. And now MOVA is designed to improve 4 areas. So work where GPS fail, which means the native SLAM positioning supports weak signal, dusty, and underground environments. And second, it can reduce field effort. And work and scan the reduce repeat tripod setup and routine capture time. And next one is support measurement with confidence. The reference precision shows there is minus 1 centimeter for MOVA and plus minus 5 millimeter for MOVA Pro. So supporting volume calculation and deformation checks and project records. So this figure shows validated against the site and acceptable requirements, and accuracy depends not only on the sensor, but also depends on the environment. For example, such as the route, the surface, or the operation method and processing workflow. And the last one, the hardware and software support, the processing, the compression, and reporting, reduce fragment handover. So it highlights the potential 5 times productivity gain and 3 meter range, and our point cloud density of up to 614 K points per second, and a 3D Gaussian splatting module. So together, these capabilities respond to the earlier pressure. So let's say the less repeated setup, the less exposure, and fewer data gaps. So again, this is a MOVA Pro product family that was introduced by my colleague Bell. So let us just review again the mobile, the optimal, the versatile, and authorized. So in the world, the value of the MOVA and MOVA Pro series cannot, the value does not come from one hardware component alone. It comes from the connection between the mobile capture, the modular extensions, processing software, and the team using the evidence. And the product supports full-board application area. In open pit mining, the focus is stockpile and dump volume checks with less service effort. In underground mapping, the focus is GPS denied spaces and limited lighting and reduced exposure. In energy and industry sites, the focus is digital twin, the deformation, compression, and a BIM or the industrial system integration. In engineering and server workflow, the focus is to the multiple project reuse and the CAD output and open formats and the scenes deployment. And utilizing same platform can support different industry, but every pilot should start with one specific problem and one measurement output. So our next session is about the move from the capability to application. So the next 6 scenarios are 6 applications of the same capture to report loop. In each case, we will connect the field problem to the data workflow and then to the business value. Scenario 1, for open pit mining, stockpile volume affects inventory confidence and production planning, settlements, and distribute resolution. MOVA supports capture the in the active, the dusty, and GPS denied area. So let's talk about the accuracy of 300 meter range and such a 614 K points per second density shows there can be cover a large stockpile efficiency, and work and scan reduce repeated setup and distribution to production. And the references precision is high accuracy for MOVA Pro and subject to site validation, and for the Kankan software supports volume calculation and export formats, such as LAS, E57, and PRY. So let's just quick go through the software process of the volume calculation. So this kind of a loop is that to capture the stockpile and calculate the volume and export evidence. In this case, we calculate the volume, the data we stored, and also the coordinates is captured. So it is used for the inventory and settlement decisions. For high wall and tailing dams, our scenario 2 is the priority changes from the quantity to safety. The multiple temporal 3D data can help identify the cracks, the displacement trends, and surface changes. A long-range, non-contact contact scanning reduces the need to send people to hazardous area. In comparison, the output can support safety reviews, audits, and technical documentation, and high-resolution 3D models can also support remote expert review, and also can achieve the loop that is captured from the safer position and compare across time and identify change and give the right expert access to the evidence. Our scenario 3, the tunnel, the underground spaces combine limited GPS, limited light, and personnel risk. So our SLAM positioning supports mapping where satellite signal, the signal are unavailable. So single person capture can reduce exposure to unstable ground, toxic gases, and other hazards. And the infrared structural light module supports detailed capture in dark or low light condition. And the output includes to use 3D tunnel model and safer record for reporting, review, and handover. Then what your team will get the highlight up to plus minus 5 millimeters as a precision reference, and lightweight handle design and integration with mine safety and management system. So let's take a look at the real cases of underground spaces for the content solution. So let us share this website. Wait a second. Yeah, this is showing the 4D CAN platform. The software is showing that it is in underground survey and it's underground documentation and digitalization output. In this panoramas mode, it can be showing the really fancy image and colors where these details are showing in with the maximum of 5 times zoom in. And of course, with field footprint moving. Okay. We'll show many details of this underground space. And of course, with the point cloud mode, so it may need times to, okay. Let's see, let's zoom in a little bit. So pixel level accuracies that makes the data measurable more accuracy, which our volume calculation also each measurement parameters can be calculated by this point cloud. So I won't go this too much further. So again, if you're interested, just can contact me or my colleague for more solution discussion. So we're happy to see you are interested in this. just move forward. Different footprints. As back to the anomalous mode. Okay, so later on we'll have a detailed video of this solution. So we will go that further in that session. So just go back to the slides. So of course, it's achieved the loop is that as we enter less equipment and less exposure to capture the underground space and create a usable mode and connect it to mine record and safety decision. So for the construction team, need to verify the quantities, the progress, and design deviations before different become expensive rework. So MOVA can help generate CAD drawings, plans, and section faster. The multi-temporal compression can identify the deviation earlier. So one operator can manage capture and processing and reporting, also the reducing the coordinate effort. So survey-grade data can support the acceptance checks, the quantity verification, and design compliance. The result is traceable evidence for progress review and acceptance and claim review. So of course, and it can be achieved the closed loop is that capture the actual construction states and compare it with the expected states, identify the deviations, and provide evidence for correction or acceptance. Okay. After an accident, it's not really everyone wants to see that, but once an accident happens, the response team needs to resolve the scenes quickly while minimizing the exposure to unstopped and unstable area. And MOVA can be deployed with minimal setup, and true color point clouds and panoramas can create precise scenes record. So these scenes can be shared online or remote expert review, while the secure offline storage helps protect data integrity. So this evidence can support investigation and legal and insurance process, and of course the internal safety review. So the operation result is faster scenes capture, a safer response, and better evidence for decision after an incident. And our last scenario, new energy assets needs records and involve overtime, not just a one-time survey. So for wind power, the workflow can support terrain survey, the turbine foundation record, the slope monitoring, and earthwork volume calculation. For the solar plant, it can support terrain modeling and layout, and structural tilt monitoring and identification of vegetation obstructions. And for energy storage and substation, and it can support digital twin, the safety clearance check, and retrofit verification and multi-temporal assets record. And this SAM's capture to report workflow can repeat it across planning, construction, inspection, and model modification and operation. And open format output and accuracy precision reference showing here can support BIM and CAD workflow subjected to the project validation. And this is the life cycle loop, and capture the assets, update it over time, and compare changes and maintain a digital record for operation and handover. So the first three sessions took us from the field pressure to a repeatable workflow and then to the 6 application. The final session show how the same spatial workflow can extend into automation and underground engineering system. So here is the robot dog. If you notice, it's different robot dog with the mobile product. So in this case, the robot dog can perform basic special routine while mobile capture surrounding environment. The value is not simple accounting and the robot is connected to people when spatial capture to construction and later review into one workflow. So next one is our underground caverns, just similar with what I was presented.
For a long time, the side road of flat tunnels relied on measuring with a tape measure and on-site drawing. Personnel need to go deep into the cave to record, with high labor intensity and low efficiency. And there are safety hazards. We have developed an image-based point cloud accurate digital side road system for underground caves, allowing technicians no need to stay in the cave for a long time to accurately extract structural planes orientation, fissure development, and other key geological elements. The system has 4 core functions, including intelligent identification of attitude, automatically generate rows diagrams, hole diagrams, one click to export CAD, Excel, and other standardized results. Supports multi-period data comparison, deformation monitoring, and stability assessment. It seamlessly connects to the BIM platform and realizes the data integration of surveying and design. This system completely transforms the traditional workflow where personnel enter caverns to draw diagrams manually, transforming high-risk and high-intensity field work into safe and efficient data processing in the office, significantly improving the safety and efficiency.
Okay, so after reviewing this video, you can imagine the project management and handover team can also work from a shared spatial reference instead of relying on the separate photographs, drawings, or verbal description. And of course, the same 5 steps workflow will still apply to capture the model and measure and compare and the should cover the sharing. Okay. Okay, it's available. So let's again just finish this workflow. Let's just say the capture, the model, and measure and compare and reports. So in this case, the border means that spatial computing to turning a difficult physical environment into a digital asset that supports the engineering decision, safety review, and long-term management. Okay, I think this is the end of today's webinar.